Alright guys, welcome back to another lesson for Algebra 1. Lesson 117 using trigonometric ratios. So for the most part you guys know these. We're just going to introduce a couple more and then we're going to start doing a little bit more math. I'm going to use a calculator for the second part of this, but it shouldn't be very hard because if you remember what we taught you in 8th grade, you're going to do fine. And obviously as we start working more in geometry, for example, in these, and in Algebra 2, and then pre-calculus, you will definitely know your trigonometric ratio. So let's actually get into it. All right, so before I get into the examples, I need to remind you of things, okay? So hopefully you guys remember this shorthand, SOHCAHTOA, that I gave you last year. And so if we divide it into the three different trigonometric functions, it's going to be sine, cosine, and tangent. Whoops. Tangent, all right? So sine, cosine, and tangent, sine, cosine, and tangent, all right? So I will get into what this means a little bit more in a second. So this one means opposite side over hypotenuse. All right, this is adjacent side over hypotenuse, and this is opposite side over adjacent. I'm not writing the whole thing because I'm trying to explain this here according to this triangle. So, first of all, obviously you need to have a right triangle. Very important. We should know this. Second of all, when we're going to do these trigonometric functions, we need to understand that they are all going to be based on an angle, okay? So the angle is very important. So in here, I got sine of angle A, cosine of angle A, and tangent of angle A. And in here, I have sine of angle B, cosine of angle B, tangent of angle B. All right, let's not worry about the new ones yet. Let's worry about this one. So it's going to be a ratio, okay? A ratio is what? A ratio is the comparison between two things. And in this particular instance is going to be a ratio between two sides. What sides? Okay. So if we look at here, it's sine equals opposite over hypotenuse. The hypotenuse is always the side opposite the right angle. So it's always going to be C. And if you remember, I mean, the Pythagorean theorem, a squared plus b squared equals c squared. C squared is always the hypotenuse. That's why I put C here. So the hypotenuse is C. And what's the opposite? What is the opposite side of angle A? Angle A is here, right here, is right here in the bottom left. And so it will be the opposite, which is A. So my sine of A is going to be side A over hypotenuse. Cosine of A, of angle A, is going to be the adjacent. Adjacent, remember, it's a preposition that means right next to, like when the desks were literally next to each other, not like in our classroom, but in like 7th and 8th grade, where they actually are touching, the desks are touching each other. That's called adjacent. And so, or tan houses. Tan houses are actually adjacent to each other. So, cosine of A, it's going to be adjacent over hypotenuse. Adjacent is B over C. And then tangent is going to be the opposite over the adjacent. The opposite of A is going to be A, and the adjacent is going to be B. So A over B. So that's how you find the trigonometric functions of this angle. What about this part? Well, that's pretty simple because what we're going to do is do it in reference to the angle that's up top here. So B, what is the opposite of B? The opposite of angle B is side B, and the hypotenuse still stays the same. What about cosine? Cosine, the adjacent would be side A, and the hypotenuse still C. And then the tangent would be the opposite over the adjacent, which is going to be B over A. Now I want you to understand something here. These have something in common. Like for example, the cosine of B and the sine of A are actually the same ratio, and the cosine of A and the sine of B are the same ratio. That's actually important to note, something to keep in mind. And then this ones, they're called the reciprocals. Okay, reciprocal, obviously the flip. You flip the numerator with the denominator, and that's what you get. So this is a very quick review of what sine, cosine, and tangent are. Okay, so that is part of the lesson. Now the other part of the lesson is understanding these new ones. Cosecant, secant, and cotangent. And I'm going to write them like that because you have to understand something. All this line right here up top, we're talking about sine, right? Whether it be sine of A or sine of B. Well, there's something that happens, and it's the reciprocal. The reciprocal of a sine, like the reciprocal of sine A would be C over A, right? It makes sense. So the reciprocal would be called the cosecant, CSC. A would be C over A. And the cosecant of B is B over C. C over B, not the other way around. My bad. C over B. Then we have cosine of A and cosine of B, and that would be secant. So secant of A is going to be C over B, and the secant of B, of angle B, is going to be C over A. So what I'm trying to tell you here is that these are reciprocal, meaning you flip the denominator with the numerator, kind of like what happens here in the tangents, but it's the same with that. And the cotangent here is the same thing. It's going to be reciprocal, so cotangent of angle A will then become the tangent of what it was before, B, so B over A, and the cotangent for angle B is going to be A over B, which is, funnily enough, the tangent of A. But that happens because these two have a special relationship, which means reciprocal, and is the same thing with cotangent. So that's very important. But what you have to understand is the flipping. The cosecant is the flipping, the secant is the flipping, the cotangent is the flipping of these for angle A. Sine of angle A is AC. Cosecant of angle A is CA. Cosine of A is B over C. Secant of A is C over B. Tangent of A is A over B. Cotangent of A is B over A. So it just flips. Now, please, 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 the one thing that I have to tell you more than anything is this. Please do not get confused with cosecant and secant, because a lot of people see this. It's sine, and they say, oh, sine is because it starts with an S, it's going to go with secant. No, 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 no. Sine always goes with cosecant. Because what happens is kind of weird. I know I have cosine here, and then I have cosecant. I know, but they don't have anything to do. Sine goes with cosecant, and cosine goes with secant. That's the way they wrote it. That's the way it is. So please don't get it mixed up. So hopefully you understand that cosecant then would be hypotenuse over opposite. Secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. Hopefully that makes it clear and you understand what we're doing. Now let's actually get into the lesson problems. All right, so the first part of example 1 is you have this triangle, and they tell you, okay, find sine of angle B, cosine of angle B, and tangent of angle B. First part of the example, then we're going to move on to the second one. All right, so the first part is find sine of B. So I wrote my little shorthand there, SOHCAHTOA. I know it has a name, but the name escapes me right now. Whatever it's called. Anyway, you know, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So, the sine of B is going to be what? It's going to be the opposite over the hypotenuse, which B is going to be 5, right? The side opposite angle B is 5, and the hypotenuse is 13, 5/13, right? Cosine is adjacent over hypotenuse. Adjacent is 12 over 13. And then tangent is going to be opposite over adjacent. Opposite being 5 over 12, 5/12. Yay, I finished. I think that's all we have to do. Yeah, we don't have to actually know what we're doing here with the calculator. Obviously, I'm going to take it out in a second when we get a little bit deeper. But at first, this is all we have to do. All right, so let's actually move on to the second part of example 1. All right, for the second part, we then have to find all 6 trigonometric ratios for angle A. So, sine of angle A is the opposite over the hypotenuse. The opposite would be 12. The hypotenuse is 13. The cosine of A is the adjacent over the hypotenuse, which is 5 over 13. Tangent of A is going to be the opposite over the opposite over adjacent. So it's 12 over 5. Note that this is actually a little bit weird because this is actually a whole a number that's greater than 1. Usually our ratios are smaller than 1, but sometimes for tangent especially is when we're going to see numbers that are greater than 1. Now let's move on to cosecant. If you remember, cosecant is the reciprocal of sine. Because as the reciprocal, it'd be 13 over 12 because the hypotenuse is 13 and the opposite is 12. Now for secant, the hypotenuse is 13 and the adjacent is 5 for angle A. And cotangent means it's going to be 12. No. It's going to be adjacent over opposite, sorry. So it's 5 over 12. And that's how we get the 6 trigonometric ratios or functions for angle A. All right, so that would be it. Let's actually move on to another example. Hooray! All right, for this part is where we get into the calculator. Look at the calculator over here. Kind of looks like mine. Yay. Okay, so it says if angle A equals 42 degrees, then you have to find sine of A, cosine of A, and tangent of A to the nearest 10,000. And that's what we use this calculator. So before you even start, please remember, you have to go to mode. And then in mode, you have to go to the third one, or fourth one, in this one. To the fourth one, instead of radians, it has to be in degrees. If it's not in degrees, you're going to get really weird answers. So, then we're going to do what it says here, which is literally you press sine of 42, right? Sine of 42, press enter, you get 0.669130600604, but you have to do it to the nearest 10,000, which is the fourth decimal place, and so it will be 0.6691. All right, so what about next? Next, we're going to put cosine right here. So cosine of 42, this is the last time I actually show you what the buttons you have to press, but it'll be 7431. Okay, 7431. And then we're going to do tangent of 42. We're going to 0.9004. Look at that. Those are the numbers they get here. What about for 33? This is where it gets a little bit confusing. All right. And I wouldn't recommend you use this part. The reason is because you'll get confused. I'd rather you do it this way. And so the way that we're going to do it is this. You're going to put, like for example, find cosecant, secant, and cotangent. There are no buttons here, unfortunately. Like if you look up here, the second doesn't give you that. That's not what it means, okay? That's called inverse, and that's not what we're talking about. And then if you try to press all the buttons and look it up, you can't. So what you have to do is you have to put 1, literally 1, divided by the sine of 33. And look what I get. I got 1.83607. In here they get 1.8361 because they rounded up the 0 because of the 7. So that's how you do it. So it's 1 over sine, and then you have to do 1 over cosine, and that's why I'm telling you, you cannot get cosecant, which is 1 over sine, mixed with secant, which is 1 over cosine. And cosecant is 1.8361, but secant is 1.1924. 1.1924. Wow. And then for the cotangent, that one's easier than the other ones, is 1 over tangent of 33. It'd be 1.5399. 1.5399. And that's how you do it. All right. So that's pretty easy. But before we move on, obviously, it's bonus time. And so today's bonus is going to be a little bit more geared towards what we're doing in geography. So I told you I hadn't recorded these classes before our first class. So we're actually going to start talking more about the Bible and stuff like that. So I want you to tell me, for those of you who are doing it on YouTube, which get more points anyway. So if you're going to comment down below, you have to tell me who your favorite preacher is, okay? And by that, I want you to know, like, it could be, you know, your pastor or anything like that. And the awesome thing is that because of what we're going through, their preachings could be anywhere. Literally, they could, because they need to be posted online. They need to be on YouTube. They need to be on Facebook. They could be on Twitch. They could be on so many other platforms that could live stream, so that their messages could be reaching their congregations. And that I love. So I just want to know, because maybe if I can get to listen to them, it's never a bad thing to listen too much to the Word of God. So that'd be cool if you could just tell me who you think it's a good preacher, and where I could probably learn more about him. And for those of you who are going to do it, so that's the first 5 people, obviously. And then for the next 3 people, I want you to tell me, and this one is not as, you know, involved as that. But the other one is for those who want to do it in, or, you know, come in late and want some more bonus points, which almost nobody does in Algebra 1 anyway, but I'm still going to do it. It's for 2 bonus points for the first 3 people to comment in Google Classroom. If you could play an instrument, what instrument could you or would you want to play? All right, because I know that most of the 9th graders don't play instruments, only like Dante and Kyle, but they don't watch the videos anyway, so it doesn't matter. Not that I know of, at least, but, you know, if you could or play an instrument, that'd be cool if you let me know. All right, so let's actually move on to example 3 and then 4, and that would be it for this lesson. All right, so in example 3, we have a triangle that's a right triangle. We have side that's x and side that's 9, and we have the angle 28. So what we need to determine is what ratio, trigonometric ratio, we're going to use. And the one that we need is one that uses the opposite and the adjacent, because we don't know what the hypotenuse is and we don't know much else. So we need to use one that uses opposite and adjacent. And the one that does it from the original 3 that you learned from last year would be tangent is opposite over adjacent. So let's put that. Tangent of 28 degrees, obviously, equals opposite, which is x, over adjacent, which is 9. Okay? So now what are we going to do? This is why you need the calculator. It's impossible for you to do it without the calculator. What you're literally going to do is find tangent of 28, which is 0.5, 317. Usually find it to the nearest 10,000th, hundredths. No, tenths, hundredths, thousandths, 10,000ths. Right? Equals x over 9. And then we're going to multiply 9 on both sides. And you're going to get that x is going to be approximately, please put approximately, it's not a correct one. So 4.7854. 4.7854. Let's see what your book has. 4.79. Oh, I'm pretty good at that. 4.78 54, 4.79. That is pretty much the same thing. So that's how you do the first part of example 3. Now for the second part of this example, we have this triangle, but then we have 2 variables. We have x and y, and they say, okay, find x and find y. So the only thing we have is the hypotenuse and the side. So we need to find sine of 52 degrees, which is the same thing as the opposite over the hypotenuse. So it's going to be x over 12. And then we have to find the cosine of 52 degrees, which is equal to y over 12, which is the adjacent over the hypotenuse. So once you do, okay, so we need a calculator, obviously. I put it in my pocket. I totally forgot where it was. But it's sine of 52 degrees times 12. I'm doing the same process I put here. That's why I didn't erase it, so that you could probably look at it. I know there's a little bit of glare, but if I don't put this light, you will see that the glare, or you can't see, but I know that the glare is worse. This actually kind of helps with the glare, so that I can actually write things kind of around here, I think it is. So x is about 9.47. This time I'm just going to do it to the hundredths, sorry, not thousandths. And then cosine of 52 times 12, because that's what we did here as well. Y would be around 7.39. And that's what I get, 9.47 and 7.39. They have 9.46. Let me see this. Sine of 52 times 12. I got 9.456. Is 46, yes, not 47. My bad. I was thinking of rounding the 6, not the 5, and that's why I got it. So this is how you do these, but obviously you need a calculator. So let's move on then to the final example for lesson 117. Okay. Please understand, this is the most important example that we're going to do today, because this one is the one that you have no idea how to do. And that's the thing. You are not going to be able to do it without the calculator. In fact, I'm not able to do it without the calculator. This is why you need a calculator. So when we're talking about trigonometric functions and ratios, you do need a calculator. There's no way around it. That's the truth. So one of the things that happens here is that they want to find the measurement of angle A. And you guys are going to be like, wow, that's crazy. How could you do that? Well, there's a way to do it. Because we know that the ratio of the hypotenuse to the adjacent side is going to help us, right? So, yes, that's what we need to find. We need to find A. I was just making sure that it was A and not B. So, to be able to find A, we need to find what trigonometric function or ratio is the one that has the adjacent over the hypotenuse. The adjacent over the hypotenuse would be cosine. So cosine of A, and you have to write it like this. Cosine of A will be the same thing as 6 over 11. Okay, so far so good. Now, you can obviously do this in a calculator. 6 over 11, that's pretty easy. But then how do you find cosine of A? And this is where it actually becomes a little bit more complicated. Because we're going to use a notation in a calculator that I will show you in a second, that it's called the inverse. All right? And it will look something like this. The inverse. And it's kind of weird what I'm going to do, so I'm going to explain it to you first algebraically, like solve it, because what we're trying to do is solve for A, literally. Here, what we have to do is solve for A. So before I do anything in the calculator, I'm going to solve for it, and you will understand what I mean. Because what is cosine of A doing? Cosine of A is kind of multiplying, right? So we have to divide. So then we would have to divide by cosine. And it crosses out. And then we have cosine over here. But cosine of what? Because that's how they work. Cosine of an angle. Cosine times an angle, right? Kind of like cosine times an angle. We can't do that right now. But we know that another notation for having something in the denominator, right? Like, for example, x to the -1 is the same thing as 1 over x. And that's where we get our inverse cosine notation, because then what it means here is that we're doing the inverse cosine of 6 over 11. And that's exactly how I want you to put it in your calculator. And so this is why I was telling you that I don't like the way that your book tells you in the first part, in example 2, how to do it. And so let's get close to the calculator. And I need you to look at the buttons, because in here, above cosine, you can see right here, it says cosine -1 to the -1 power. That is the inverse cosine. And that's literally how you're going to find this problem. You're going to put second cosine, and then you're going to put 6 over 11. It doesn't matter if the fraction is like this, or if you want to be more correct, you can put a fraction like this, 6 over 11. So that not everybody is like, oh my goodness, he doesn't know how to use a calculator. I know how to. So there you go. That's called inverse cosine of 6/11, and you will get something like 56.94, and that would be my angle. Angle for A is, let me switch to the deeper camera. A is about 56.94 degrees. Is that what your book has? Oh, look at that, 56.94. And that's how you do it. So let's then look at the last example, and then we'll be done for today. Okay. For the last example, this one is about finding the measurement of angle A and the measurement of angle B. So this is really important because we don't have a hypotenuse. So we can't use sine, we can't use cosine, we have to use tangent. So we're going to use tangent of A equals opposite, which is 2 over 5. That's for tangent of A. And for tangent of B, it would be the reciprocal, 5 over 2, right? Now we're going to go back to our handy dandy calculator. So let me, oops, sorry, bumped you there. All right, we're going to go to tangent. And as you can see above tangent, we have the tangent -1. So second tangent. And then let's put the little fraction thing that's fancy, because now people will be like, you know how to use a calculator. It's going to be 2 over 5. Oh, I could have just put 0.4. I'm going to do that for the next one. Well, the next one is easier because it's 5/2, which is 2.5. So we have 2 fifths. Then we press enter. We get our first angle to be about 21.80, right? So 21.8. And then for my second one, I press again second tangent, and I put 2.5 because that's what 5/2 is, and you'll see that it's 68.19. Now, if you want to see something really weird, if I add 21.801 and whatnot plus this number right here, what number do you think I should get? 90? Boom, 90. Because they should equal 90 degrees. That's how I know I got them right. And so my answers are, for angle A, it's about 21.8 degrees. And for angle B, it's about 68.198. I could say about 68.2. I'm going to put it that way. I know that your book might not have it like that, but it's just easier this way. So that would be it for how you do these examples. Obviously, remember your calculator. Pretty easy. Yeah, I will see you in the next one. We have 3 more classes to go. Hooray us. Hooray us.